All right, welcome everyone. I'm going to give folks a few moments to join here, and then we'll start off with a quick introduction. All right, looks like we've got a good amount of folks jumping in the room already. So thank you everyone who's joining us today for Surface-Tolerant Coating Solutions. It's presented by Katie Duda, the Director of Industrial Products at Tnemec. We've also got Jennifer from Tnemec on today, who's hanging out in the background. She'll be around to help answer questions towards the end. So really want to encourage folks to submit questions to the Q&A throughout today's presentation. We should have some time to get to those questions live, and if we don't get to them live, we'll have a record of it and we can follow up with you after today's event. Before we get started with the CEU approved portion of today's webinar, I just want to take some time to give y'all a few resources for after today's webinar if you're looking for some more information about some of the solutions that we're going to be talking about today. So Katie, I'm going to take over screen share for a moment just so that you know.
Sure.
All right. You should be on my screen now. So everyone who signs up for today's webinar has a free Acelab account. We've got tons of great resources here, so definitely check out this website after today's webinar if you haven't already, and take a look at some of the really great resources we offer for architects. What I want to show you today is just how to get some more information about Tnemec and their products if you're interested in exploring some more after today's webinar. We've got this great search bar at the top. You can always type in the name of any brand, any product. It'll cross-search between all the resources that we have on Acelab. So just make sure you're selected on that brands tab and head over to the Tnemec page on Acelab. From here, you can get in touch with the Tnemec team directly. You can use this contact button. That'll create a message with their team. You can reach out about a project or just some more general information. So this is a great way to get in touch if you're looking to connect with today's presenters. Scrolling down here, you can view some more information about the company, and you can also explore their products. You can save these to your account for future reference. And you can also open up any of these product pages to get some more information about those products, access downloads, get in touch with their team here as well, get your brochures. So this is a great place to come for some additional resources after today's webinar. We also will give you the option towards the end of today's webinar. If you are interested in getting connected with Tnemec, you can let us know through a poll later on. We'll go ahead and connect you with them on your Acelab account. You can find your Acelab conversations in the top right here. This is a great place to come to just get an overview of all of your conversations. If you've been to a webinar with us in the past, this is a great place to come and check out. You probably have some resources from some webinars in this account as well. You're also going to receive emails about any messages on Acelab. You can respond directly to those emails, so you don't have to open up the Acelab platform, but it's a helpful place to get an overview of all of your communication that you've done with Acelab. All right. Other than that, a few housekeeping items from me. So today's webinar is AIA CEU approved. We did ask for AIA numbers upon registration. We will also send over a form in the chat later on in case you're worried you didn't submit your AIA number, you need to request a certificate specifically. You can do that. If you've attended a bunch of webinars with us in the past, that information in the form auto-saves, so you don't need to fill it out again, but it'll be there in case you need it. Reminder to submit questions to the Q&A, and we'll also have a quick post-event survey where if you have any questions that come up as you're leaving today's event, you can submit them there as well. All right, that should be it for me. Thank you everyone for joining us today. I know it's, the week before a holiday break for most people, so we appreciate everybody who took some time to come out and learn some more with us. All right, Katie, whenever you're ready, feel free to go ahead and share your screen again and get started.
Okay. Let me get that going. Does that look okay for everyone?
Looks great.
All right. Okay, well, I'm pleased to be your host today. Again, my name's Katie Duda. I'm the Director of Industrial Products for Tnemec Company. I'm broadcasting from beautiful Western North Carolina today. Sorry about the sun in the background, but glad to be with you and during the holiday season and for everyone who has put their schedules together, because I know it's not so easy this time of year. So we'll get started. Just a quick overview. I think Bo covered most of this. Tnemec is a registered provider for AIA. This is educational activity protected by U.S. international copyright laws. We're about to get into the course description, but this is worth one learning unit for you today. And our learning objectives are to understand the purpose and advantages of surface-tolerant coatings, identify key characteristics that differentiate surface-tolerant coatings, explore various types of surface-tolerant coatings and determine their ideal applications, and assess and evaluate coatings using performance data to make informed decisions. So With that being said, let's start out with some statistics from a corrosion paper number 3001, and it's regarding life cycle potential for newly installed coatings versus overcoat systems. So let's start with that 100%. That's the life cycle potential of a new coating installation. Okay, let that soak in for a second. 50 to 80%. That's the approximate life cycle potential of a properly selected overcoat system. Again, according to the corrosion paper 3001, which is based off of some really good test data and some project history. So I do urge you to take a look at that. But let's do some easy math with this and start to mess around with a nice round number. If we have a new installation that should give us about 20 years of service, a proper overcoat installation could potentially give us an additional 10 to 16 years of service. Now let's compare that to 10% or less. That's the life cycle potential of a poorly selected overcoat system. So more easy math there. If we make a poor decision, we could get as little as 1 to 2 years of additional service life with an overcoat installation that is not very well thought out. So that's what we want to avoid here. So the dreaded definition that coating manufacturers and technical representatives hate. What is a surface tolerant coating? We're never supposed to compromise surface preparation efforts, right? Oops, sorry, let me go back. But it's also the definition that, sometimes our contractors love to hear because it's like, oh, this stuff will stick to anything. But contrary to both of those descriptions, surface tolerance should be described as coatings and systems that allow us to all do better at addressing the challenges that we really do face in the field every day, which is typically different degrees of rust, and how to address aged and existing coatings. And the surface tolerant solutions simply help us to better address service areas and situations that we can't always get what we want, and therefore we're able to maximize the life cycle potential. So what happens when we can't always get what we want? To be clear, we are not talking about coating over loose material, whether that's loose rust or loose coatings. We're not talking about coating over bird poop and feathers, which is also a different scenario that some of us may have seen as well. But what happens when we can't always get the surface preparation that we do want? We typically lean on recommendations that we know are absolutely correct, or we shy away from alternative recommendations. But if there is no budget, if there's not enough budget, not enough time, not enough access, or maybe the asset is nearing the end of its life cycle, the wrong alternative is to do nothing at all. And this is why we want to dive into this question of why do we use surface tolerant solutions? And we dive into surface tolerant options to bring value to our end customers, users, and owners. And with that said, let's go back to our title. The surface tolerant coating solutions, how to extend maintenance cycles to maximize service life. Let's look at it just a little bit differently. If we can extend the maintenance cycles and maximize service life, these are two important things that owners and operators love to hear and love to achieve. So if we can effectively extend the maintenance cycles and extend service life, we will bring value to our owners and operators. But we have to get the systems right, and we really do have to understand what we're talking about. We want to bring the best solutions in these challenging situations and therefore the best value to our customers and prospects as well. So let's do an overview here of what we're going to cover, literally. Where to use surface tolerant coatings, the key characteristics of surface tolerant coatings, types of surface tolerant coatings, performance testing for surface tolerant coatings, the coating system selection process, and success stories, of course, to finish off. So I know that I don't get too many calls that start with, hey, I have this perfect substrate that I need to protect. And this is where I would love to ask for a show of hands to see how many of you out there also get that question. And in webinar world, it's not really possible. But seriously, when are we looking for these types of surface tolerant coating options? Maybe here, I see some issues. Or here, I see some more rust challenges here. Or how about any of these? What do they all have in common? They all have corrosion issues, some more than others, and they all have existing paint, some more than others. How about this one? Condensing or damp substrates. It's important to note that surface tolerant doesn't just pertain to rust or marginally prepared substrates. Sometimes we must also address the application conditions that we can't always control. How about this one? Good condition, wrong logo. What happens when there's a nice existing coating, but maybe the wrong color or signage for whatever reason, something may have gotten sold. Whatever that reason is, we still need a solution. So the point I'm trying to make here is that when we bring up surface tolerance, we're not just talking about the rust. These coatings are designed to adhere to marginally prepared surfaces, including tightly adhered rust, but also other residual contaminants and, more importantly, aged coating systems. And when we're talking about any type of coating, it's always good to review the coating life cycle. So we can go back to our original stats, that 100%, that's the potential that we have when we replace or have a complete replacement of a coating system. According to NACE paper 10673, and there's several versions out there, so I apologize if that's not the latest one, but regarding the estimated service life of different coating systems exposed to different corrosivity categories, and based on the type of surface preparation, these estimates provided in this paper are based on the time to practical maintenance. And this is when about 10% of the coating has degraded to the substrate. So this is this area right here. If we go back to those original statistics, when we get to the maintenance phase, we can achieve 50 to 80% more of coating potential if we make a good decision with an overcoat. And that's versus 10% or less if we make a bad decision. So it's really important that we make those good decisions. And if we can extend or spend more time in the repair and practical maintenance phases by implementing better coating selections, then we are going to maximize the amount of time we spend in these areas. And therefore, it's going to be, we're going to help reach our goals to provide more value to the end customers by maximizing that service life. So now let's get into the characteristics of surface tolerant coatings. What are the key properties? So when you go to 0 to 100, what does that actually mean? And that's a good question, because that 0% to 100% is referencing tight material when we're talking about surface preparation. The commercial blast clean, it's kind of like the standard for most of our exterior exposed paint systems, or what you're going to see referenced in most technical data sheets. This allows for 0% of any material to remain on the substrate. But how do we estimate performance when we can only achieve a hand or power tool clean, which allows for 100% of tight material? Most exterior coatings are designed to work well over a commercial blast clean, but only some will work well over tightly adhered material. And those coatings, the surface tolerant coatings, typically have the following characteristics. First one up, adhesion. How well does it stick? This is determined by the wetting characteristics, and surface tolerant coatings need excellent wetting, even to less than ideal surfaces. And this is how adhesion works in a visual. The goal is high surface energy and low surface tension. You can see at the top that the low surface energy has a tendency to create droplets. And those bead up, which can create voids in the coverage to the substrate, and where high surface energy allows for better coverage and better wetting. And when you have better wetting, you have better adhesion. Next one up is corrosion resistance. Surface tolerant coatings typically offer protection that is boosted by chemical properties like rust inhibitors or physical properties like enhanced barrier protection. Versatility and compatibility. Surface tolerant options should also be suitable for a variety of circumstances, like direct to rust, overcoating age systems, or applications during challenging ambient conditions. As we had stated before, it's usually not just one of these. We need to figure out how to deal with all of them or more than one. And finally, ease of application, another needed characteristic. You can have all of the other characteristics nailed, but if you can't successfully apply it, it will fail or it's not going to perform as intended. So the ease of application does refer to the ability to apply successfully with different options or different levels of expertise, whether you're brushing and rolling or spraying, or even implementing a dry fall or spray safe application. You need to be able to transfer it efficiently and effectively to save time and ultimately reduce labor costs. So let's keep these key characteristics in mind. We have adhesion, corrosion resistance, versatility and compatibility, and the ease of application as we talk about the different types of surface tolerant coatings. Now, this is where we get into some different categories and the technologies defined by the service requirement. We hear a lot of tag words out there regarding surface tolerant coating options. So hopefully this is going to provide a better understanding of the different technologies that are available today and what those mean. So let's start with mastics. These are thick or viscous coatings. They're usually very user-friendly for brush and roller applications. They employ non-reactive additives or modifiers. That means that they don't react or affect the molecular structure or cross-linking, but they do give the coating additional properties like high build capabilities, higher flexibility, and with higher flexibility, you get lower cure stress. And with lower cure stress, you get good barrier protection. The next type of coating that you might come across more often regarding surface tolerant or flexible epoxies, or you might hear them referred to as flexibilized epoxies. And these types of coatings typically offer more versatile viscosity for various application methods, even ultra high solids. These types of coatings will use non-reactive, where the mastics use the non-reactive modifiers. We're going to use reactive modifiers here, which this does actually modify the cross-link structure of the coating. So you can see to the left that certain cross-link patterns, which may be good for permeability, can lead to more rigid films. Altering this cross-link pattern can allow for more flexible films. And this is why these types of coatings, which may have very good chemical resistance, may not be the best choice for an immersion grade coating or liner. But just as the coating says, it does offer higher flexibility. It provides lower cure stress, and it's a better option for existing or compromised coatings. Next one up is high build coatings. Now, this one's not always associated very specifically with surface tolerance, but I like to bring it up because I think it's pertinent to define it. They do have premium films or barrier characteristics when we're talking about surface tolerance. So it's nice to be able to achieve these characteristics in one coat. And while some definitions may vary from manufacturer to manufacturer, we're typically talking about builds of 8 to 10 mils per coat. That's without sagging and it's without compromising the film integrity. This offers higher sag resistance, customized barrier protection. It may be used with reactive or non-reactive modifiers for added flexibility. And it offers customized barrier protection. So while the build's nice, you may not need it everywhere, but the ability to have it where you need it can be important. So these technologies can be used across a wide range of areas. The last major category that we're going to dive into is elastomeric coatings. And these are dense, durable, elastic, sometimes offering 200% plus elongation. They're lightweight, the ability to bridge small cracks, corrosion resistant, high build capabilities, which aids in excellent barrier protection. And as an added bonus, some of these technologies can also offer dry fall or spray safe capabilities. So now that we have better defined some of the technologies that are used for surface tolerance, how do we compare them to our standard offerings? So we know that standard epoxies offer good to excellent corrosion protection. That's not a question. But this is typically over properly prepared or blasted substrates. And standard formulations do have higher cure stress, which is not a factor when you're applying directly to properly prepared substrates. But they do play into situations where the cure stress needs to be addressed. So if we are, let me see here, go to epoxy mastics, also very good corrosion protection, very specifically over hand or power tool clean substrates, and they offer low cure stress. We can then go to flexible epoxies, very good corrosion protection over hand or power tool clean substrates, also low cure stress. And I didn't mention why we have the dry fall over here, but that is typically one thing that we want to look at as well when we're talking about surface tolerant, because we're typically not having containment, and having a dry fall property is also an important thing to look at. So then when we go to our acrylics, our elastomerics, emulsions, and otherwise, also very good corrosion protection over hand or power tool clean surfaces, low cure stress, and this one can also offer our dry fall or spray safe application advantages. So as you can see by performance category, we can achieve very good corrosion protection with all these technologies over the intended substrate. And the surface tolerant options are going to have lower cure or shrink stress over the existing coatings. And the acrylic formulations are also going to offer the widest range of application options, including the dry fall or spray safe applications. So how do they all measure up? We're not trying to downgrade the standard options here at all. They're needed and they have their place for sure. But when we have other challenges, such as the limited surface prep, the existing coatings that we need to account for, and application limitations, we certainly do have options that are going to provide the same or better performance in these very specific scenarios. So let's jump into some of the performance data. What are we looking at here? What's the right stuff to look for? The right stuff, or the right test data to review, is data that actually represents the real scenario, preferably the one you're dealing with, right? Makes sense, but we don't always see that. All manufacturers have a lot of test data pertaining to specific standards, and all very useful in evaluating coatings and comparing them. Jack Walker from our group hosted a great webinar just a few months ago on this very topic. But how does that pertain to comparing the surface tolerant coatings when standard testing is typically conducted over the recommended surface preparation? How do we know how things are going to measure up? For example, if the available performance data is all over an SP6 or SP10, which is typical depending on the type of system, this is a commercial blast or a near white metal blast, but I can only achieve this, an SP2 or a hand tool power cleaned substrate, can I be sure that performance will be the same? These are very different surface preparations. They don't even illustrate the actual differences that are seen in the field when you may be coating over various different rust grades or various aged coatings. And we can certainly compare performance between coatings tested in the same way, but not necessarily determine how those same coatings will perform over a different preparation or different age systems. And the type of testing does matter. So it would kind of be like saying if a liner tests well with water, it should be fine with wastewater, right? Very wrong. Those are very different types of exposures with very different challenges. But do not fear. Some manufacturers have made it a priority to provide the right testing for surface tolerant offerings, but it is up to all of us to look for the right performance data when it comes to making the decisions about coatings used over marginally prepared substrates. For example, the adhesion data that you should be looking for with surface tolerant coatings should be limited, should not be limited to the preferred standards. We want to be looking for adhesion testing to different rust grades, preferably D. D is the worst. We want to have adhesion to other aged coatings, but we don't want to stop there. We want to think about ways to accelerate it. Our fear with overcoating tight rust or other coatings is the ability to actually keep that bond over time, not just the initial bond. Paints are made to stick to things. I mean, that's just the inherent properties of it, but we want to make sure that it's going to stick and adhere over time. So how do we mimic these changes and stresses that we might see with weathering, service changes, changing exposures? You should be looking for additional stresses or testing that mimics these. I like to see multiple cycles, modified freeze thaw testing, for example, prior to pulls. I like to see 10 plus cycles to really evaluate to see if what these types of stresses will do. And then you'll be able to see how that coding is going to mimic the scenarios of real life, including ambient conditions, cold weather stresses, cycling temperatures, or even wet, humid, or immersive type situations. This is where we want to see how far we can take the coatings and understand how they're going to perform. So let's take a look at some real numbers again. 665 PSI. There's a number. 758 PSI. Another pretty decent number. 883. These are real adhesion readings over a rust grade D after 10 cycles of freeze thaw. That's from a leading surface tolerant epoxy mastic with a high build capability. So real numbers there over real test substrates. How about 1000 PSI? That's a real adhesion number over an aged aliphatic urethane, also after freeze thaw cycles. And that one's coming to us from an acrylic elastomeric technology. So it is possible to get good results. How about no blistering, no cracking, no rusting, no delamination, no creep from the scribe after 5 cycles, which equates to 1,680 hours. That's a real result after a modified Aramco test with application of both coats to a damp surface. Over a rust grade D, that's the worst one, by the way. And that one comes in from another epoxy mastic high build formulation. So again, very good results from an existing coating. So performance matters. Testing matters. Having the right testing to promote surface tolerant solution also matters. So do all surface tolerant coatings perform this way? No. But having the right test data does help us make the right decisions. So let's go into the coating system selection. This is the fun part. This is where we put all this information together. And as we mentioned from the start, it's the most important piece to reaching our goal of maximizing our service life, which is how we add value, the whole reason that we're here. So remember these stats, the 50 to 80%. It's the coating's life cycle extension potential versus 10% or less. So why the big swing? In years of service, this could be the difference between 10 to 16 years of additional service compared to 1 to 2. That's huge. The success of us extending that maintenance cycle and maximizing the service life is based on the good coating selection versus a bad one. So a good coating selection requires a few different things, an evaluation and the pressure's on. So we want to make sure that we have or we understand the existing coating condition, geographic location, coating compatibilities, and the evaluation of a test patch. I have an asterisk here noted here because this is not always feasible, but it is one of the best practices to ensure success. And we'll get to that in just a second. So to truly understand the condition of your existing coating, you do need to conduct a proper coating assessment, which needs to include the evaluation of the degree of rust, adhesion, film integrity, and the total build of the system installed. This is all important stuff. Important enough for several ASTM standards. There's lots of them out there. Evaluating degree of rusting on painted steel surfaces, evaluating the degree of blistering of paints, measuring adhesion by tape tests, or conducting that test patch to assess coating compatibility. These standards all help us evaluate the conditioning of an existing coating system, which is very important for us to make these good decisions. Next one up that we need to take in consideration is the geographic location. Are we prone to any freeze-thaw cycles that will create additional stresses on the coating system? We can use this information gathered from the coating assessment, along with the evaluation of the geographic location to determine our delamination risk factor, or what is the degree of risk associated with us putting another coat of paint on this system. There's a lot of numbers here, so let's see if we can break it down and make it a little easier to look at. So first, let's look at the adhesion results. In this case, a cross-cut adhesion result that we see in column 1 right here. 0 rating is poor, so that's easy to see here. 5 is excellent, also easy to see here. So the delamination risk factor is actually the direct inverse of the adhesion result. So that kind of makes sense too. If we have very poor adhesion, we're going to have very high risk. If we have very good adhesion of the existing system, we're going to have very low delamination risk factor. So that's pretty simple. If you have poor adhesion, your delamination risk is high. If you have good adhesion, your delamination risk is much lower. We need to also look at other stresses to that system. We're looking at 2 different stresses here, and we're going to add a 1/2 degree of risk factor for each of these other stresses if they're present. So let's take a look at what that looks like. Let's say we have a 3 on our adhesion results. That's pretty average. That's going to give us a pretty average delamination risk factor. But now we need to take into account the geographic location. Let's say we're in an area that's going to experience some freeze-thaw cycles throughout the year. That's going to take us from our 3 to a 3.5. That's added stress. It is going to increase our delamination risk factor. Now, what if we're going to go over an H system that has a high existing total film build, say 15 plus mils? That's going to take us from our risk factor of 3.5 to 4. So that factor is important for determining our coating options and our compatibilities. So remember this number 4 because we're going to use it. So our coating options and compatibility needs to take into account the delamination risk factor and then the cohesive stress factor of the different types of coatings to determine the best candidate. So coating options, compatibility, delamination risk factor, cohesive stress factor, all important things here. The cohesive stress factor, or the cure stresses for our most common coating options, are listed here. So 1 representing lowest cure stress, 4 representing highest cure stress. So you can see our standard 2-part epoxies and urethanes have the highest stress rating for existing coating systems, while the acrylic options are going to have the lowest stress ratings. So pretty easy to see there. If we put it all together and we use our delamination risk factor, which is determined by the coating assessment and the geography, we determine compatible options based on stress factors, along with our knowledge and testing on the matching products. And then we can make a smart coating decision. So this is putting it all together. Remember our delamination risk factor before. Told you to remember number 4. So let's use that rating to take a look at our best options for that scenario. 4 is on the higher side, so it does limit our options. And you can see it here. It limits to our 1 and 2 elastomeric acrylics and acrylic emulsions. We can be confident in recommending these technologies, and we can be confident that this is a smart decision so that we can maximize our service life. So smart decisions equal success. And that's what we're trying to do here. So now let's take a look at some of our success stories, smart selections that really add value. First one up here, this is Fair Oaks Corporate Center in Fairfax, Virginia. It was office roofing refurbishment where they were going to be able to do a brush off blast and overcoat. You can see here kind of a zoom in of what the initial substrate was looking like. So there were some challenges there. But using a surface tolerant flexibilized, it was a polyamidamine epoxy primer. It was designed for marginally prepared surfaces as well as compatibility with the existing coatings. This allowed for an overcoat project that came in at half the cost of a complete replacement. This project was completed in 2003. Say that again, 2003. Still performing well. That's 21 years later. So there really can be success, even far above some of the numbers that we've stated earlier. Next one up, this are methane spheres. So sphere tanks located in Florida. Challenge here was overcoating an unidentified aged system, as you can see in this picture here. Not great substrate situation. Age system unknown, as I said, likely an epoxy urethane because that was a standard specification, but a flexibilized epoxy allowed for lower cure stress over that existing system that was remaining, while also providing a cross-linked barrier protection with good chemical resistance. So all important in this atmosphere. It was top coated with an intermediate of an elastomeric and an acrylic emulsion finish coat for added barrier properties and UV protection. The project was completed in 2017, 7.5 years in service, no issues and no visible degradation, which means there's going to be many more years of service extension here as well. This is in a refinery in Louisiana. A horizontal tank. This was previously insulated tank that had some CUI issues, but limited access and time to prepare and convert it. So this project was completed in May of 2020. The after picture that you see over to the right, that was taken earlier this year. So still looking very good with no signs of degradation. So that was not a picture taken after the project was completed, but this year, as I had mentioned. So elastomeric acrylic and acrylic emulsion was the solution here, performing quite well. This is a fun one. It was a test project for the Minnesota Department of Transportation. Test patches from 4 manufacturers were installed over age systems to evaluate the alternative top coat options when removal of an existing system was not possible. So this was a test. This is a fun one here. Take a look at this. You can see the initial adhesion results in the top right picture. That would be a 0 rating on adhesion, or the highest delamination risk factor you can possibly have. This would very most likely be a situation where you would not entertain overcoating at all. But the engineer had the comment to the left, which is pretty exciting. I was surprised. The acrylic surface tolerant system, when tested against competitor epoxy urethane systems, had the fewest deficiencies of any system evaluated after 4 years. Pretty impressive stuff. And that goes to show that you have to make the right decisions of what you're going to overcoat for that to perform in the best way. Some of the standard coatings, which would normally perform very well over a properly prepared substrate, just were not the best match here. This one also at a refinery. This was a dry fall or spray safe system for a storage tank that was going to be spot primed and overcoated. This is an updated picture taken in August of this year. The original project was completed in April of 2018, so 6.5 years in service. And as you can see, no signs of degradation. So we're going to get a lot more years out of this one. It was a dry fall acrylic system installed to address surface tolerance as well as application challenges. They had limited time and they needed to spray apply. The spray safe technology here allowed for surface tolerance as well as faster spray application compared to brush and roll without the need for any containment. So you can see met a lot of challenges there with the surface tolerant option. This is a coastal water tower, so an elevated water tower. We're limited to an SSPC SP3 or power tool clean and an overcoat over an installed system. That system was also unknown. You can see some of the evaluations here. The delamination risk factor was a 3. So mastic and flexible epoxies as well as elastomeric acrylics were all approved for this project. Ultimately, acrylics were used and are performing well. You can see all of the after pictures here. Those are current to this year as well. This one kind of shows, how it can also address bridging and existing coatings and really kind of holding those down as well. This is Boardman Tower, Washington, D.C. So luxury apartment building, a little bit different here. This was a minimally prepared surface and required an overcoat. The original project was completed in 2015. The owners were looking for the longest service life, along with compatibility to existing caulking and coatings. So this was a solution that has worked and has continued to work. In a different type of architectural situation. Bryant-Denny Stadium, University of Alabama. Stadium seats, limited to SSPC SP3 hand tool clean, or power tool clean, excuse me, and an overcoat. So it wasn't feasible to contain the area for blast cleaning. And the seat frames were power tool clean. They were primed with a surface tolerant polyamidamine epoxy, flexibilized epoxy with superior adhesion properties and enhanced flexibility. This added to the compatibility to existing coatings, specifically solvent-borne coatings. I knew it was a solvent-borne coatings. It was completed in 2006, top coated with a fluoropolymer top coat, and the stadium seats are still looking good 19 years later. So again, showing some real extension to service life. So in summary, understanding surface tolerant technologies and where they work is really key to making the right coating selection. The right surface tolerant solution can provide a viable extension to maintenance cycles. And extending maintenance cycles with the correct coating selection maximizes your service life. And the maximizing of service life reduces your maintenance costs, and that's what truly brings value to all of our end users and owners. And this is where I can leave you with a song that may be stuck in your head, because sometimes we can't always get what we want. But if we try and we really pay attention to all of the things that we have just covered, we just might find that we get what we need. So that kind of summarizes that. I appreciate everybody for paying attention, and I would love to hear if you have any questions.
Awesome. Thank you so much, Katie. Looks like we do have some questions. If you have not submitted a question yet, you can use the Q&A to do so. You can also raise your hand and we can unmute you if you've got like a longer-winded question that you want to ask out loud. You don't have to turn your video on, but that can be helpful if it feels like a lot to type out. So feel free to do that and we'll keep our eyes on those hand raises. All right, let's start off here. Are overcoat systems ever used on traditional cement stucco surfaces with surface cracking issues?
Yes, and I think it's still it's just, you know, a lot of the things that we had reviewed here were over carbon steel, but a lot of these coatings are approved for different types of substrates and different applications. It's always just important to really understand what you're going over. So if we're talking about cracked substrates or cracked stucco and things like that, there's going to be limitations that you know, just like in the first few slides, you know, we're not talking about going over loose rust and loose coatings. We need to make sure that we're making smart decisions. So we don't want to just go over anything. That's not going to maximize our service life. So we need to understand exactly what we're going over and make smart decisions there. And there's going to be certain things that will bridge small cracks and crevices, and certain coatings that are not made to do that. So we just need to understand what those limitations are for the coating, and also what our substrate or our surfaces that we're going to address.
All right, awesome. Looks like we don't have any other open ones. So while we give everyone a few more moments, see if any other questions pop up, I'm going to do a quick recap of something that we covered at the beginning, just in case some folks hopped in a little bit later and missed our quick intro. So if you've got questions that come up for you after today's event, or you want to connect with Tnemec in the future, explore some more about their products, this is a great place to come. We posted a link to this in the chat, so feel free to grab that before you head out for the day. And scrolling down here, you can use this button to get in touch with their team directly, explore some more about their company, as well as explore their products. And you can save these to your account so that you can reference them in the future, save them to either your firm library or to a specific project if you're working on some projects on Acelab. And you can also open up any of these product pages that'll give you some more information about this product. a description, as well as the brochure. So this is a great place to come if you're looking for some of those downloads as well. All right, looks like we do have another question that came up here. What would the relative costs be if added to your decision chart for each type of coating listed?
I'd say that again.
So it says, what would the relative costs be if added to your decision chart for each type of coating listed?
Or is the question the added cost for overcoat versus replacement, or for the different types of coatings?
I think it's for the different types of coatings, Katie.
Oh, for the, okay. So,
Yep.
so yes, the different types of coatings do have different costs associated with them. It really kind of comes down to what you're trying to achieve. So, you're going to have to really evaluate, what your current surface or application characteristic is, how many more years you would like to get out of it. So if we're referencing that NACE document, which gives you estimated service life, that's just one thing to reference. Different manufacturers will also have project histories and things that will give you references of how long that's going to last. That those different coatings or different systems, how much you can build those different systems, all play into what your estimated service life will be. And when you are then implementing that as an overcoat system as opposed to a recoat, then you're really kind of estimating that you're going to be somewhere between 50 to 80% of what that original service life would be. And then you can divide that by how many years and what your costs are. But in general, these all can kind of range, based on the different types of technologies, acrylics, epoxies, urethanes, fluoropolymers. They're all going to have different costs involved with them, but you'll also want to know what the service life extension is going to be, so that then you can give your real yearly estimate of what that cost is,
Right.
or the advantage or value moving forward.
Mm-hmm. Yeah, it looks like that person who asked that question did give some more clarification. They were wondering, yeah, different types of coatings applied per square foot area and thickness.
So those numbers actually are included in that NACE document. So we can give you some of that information. I will add that NACE document is an opinion paper, because it's a conglomeration of a lot of manufacturer, engineer, and user opinions. So it is while it's something, very good to reference, you're going to get more solid information from test data plus real project profiles or project case histories that show you, how these things are going to work in different environments. But the nice thing about that document is it does break it down into corrosivity categories, the different types of surface preparation that you're going to have, how many coats that you're putting on, and approximate mills and things like that. So it is a starting place to start understanding what your options are and where you can make some better decisions.
Right.
Then I would take that to the manufacturer and get more specific information on tests and project profiles.
Right. All right, next up, does Tnemec still offer a stucco restorative coating originally applied over multi-wife brick exterior building walls?
I'm going to divert this one to Jennifer, because I think she is the expert here.
See, Jennifer, are you still with us? Cool.
Yeah, I am. Yes, we do have a couple of different options. I'm not sure exactly which product you're referring to, but yes, we do have a few different an elastomeric option as well as an acrylic option. So yeah, we can reach out to you after the webinar and provide some of that information and your local representative to connect with you on that. So
awesome. All right, great. Well, it looks like that might have wrapped up questions for today. So just want to remind everyone before you jump out for the day, feel free to grab the link in the chat to the Tnemec page on Acelab. You can use that to follow up with their team after today's event. There is also going to be a quick post-event survey. Feel free to leave any questions, feedback there that comes up for you as you're leaving today's webinar. We appreciate any feedback you can give us there so we can make sure we're bringing you content that's applicable to you. All right, awesome. Well, thank you everyone for coming out on a Thursday before a holiday week. We appreciate you joining us, taking some time to learn some more about Tnemec and about their products. And thank you so much, Katie, for a great presentation, and Jennifer for being on today as well.
Thank you. Happy holidays all.
Happy holidays, everyone. Bye.
Bye-bye.